All right, and here we are now at the bottom of page 1 for section 4.3. And I'm just going to make sure, can I reference the, yeah, you can still see the slope definition here. The definition of slope is the line's movement from one point to the other, or it's a measurement of the steepness of the line. And to be more clear about what that is in terms of how we'll discover it using math and algebra, it's a ratio. It's going to be a comparison of two values, okay? And we looked at ratio in section 3.2, ratio and proportion. So it's a comparison of two values, and the way we would define slope then in terms of a ratio would be the change or the difference in up and down movement. Either it's going to go up or it's going to go down. And we would be comparing that to, again, we're trying to move from one point to the other. So as we move from point to point, you would describe its slope as a ratio of the change in up and down movement to the change in left and right movement as you moved from one point to the other on the line. So that's quite the description. That's pretty verbal there. Let's see if we can come up with a little bit more visual or a simpler way to describe that here. So if we're saying slope is a ratio, it's a ratio of the change in y, which would be representing of your up and down. That's the up and down, straight up and down axis on the grid here. That would be our y values. And it's compared to our change in x. So ratios can be written as a fraction. And that's something we learned in 3.2. So change in y over change in x. You can even, but you can represent this a couple different ways. You might see it or hear about it as a delta y over delta x, where the triangle is the Greek letter delta, and it means change. So it's change in y over change in x. Even more simple, which is what we'll refer to it often, is it's the rise of the line compared to the run of the line. It's your up and down movement compared to your left to right movement as you go from one point to the other. And it's represented in algebra by the letter M. Now, no one knows for sure why M was chosen originally as the letter to represent it. There's lots of theories out there, but there's no notes in anybody's math papers from long ago why they chose the letter M. There's some theories out there that perhaps it came from the French word monter, which means to climb. But again, we don't have any documentation for that. I like to think of it as M represents movement. Again, that's not originally where it came from, but it works pretty nicely for our purposes. So, and not only do we have a letter to represent it, but we also have a formula to be able to learn it by. So, M is equal to how the line moves, which is why I love that it's the letter M, how the line moves from one point to the other. And again, any 2 points on the line will give you the same slope ratio or the same value of slope. So if we have 2 points, on a line, let's call point 1 here x and y, and in pink here we'll identify point 2 in x and y. And now I'm going to add some extra math notation here, because when we start to put 2 points in a formula together to find slope, pen color might not be enough to keep things straight, and you might not walk around with a bunch of different pen colors handy. So we're going to give these some labels. So the first point will be x1, y1. This just means subscripts to note that these are from point 1. Okay, and then point 2, we'll call this x2, y2. And again, those little 2's are just subscripts to note that it's point 2. Okay, those are the coordinates from point 2. I'll be using colors to help us see it as well. Okay. Now, there's a formula for just about everything in mathematics, and by now you might have caught on to the fact that formula means something you're going to have to memorize. And indeed, you're going to want to memorize slope formula. Not only because you're going to need to bring it to the test and be able to use it, but when you memorize something, it moves the mathematics along. You don't have to stop and look it up or punch it into something or second guess yourself. When you memorize something, you have it at the ready and you can move on to bigger and better things. So just a little plug for building that brain muscle that handles memorization. And the way you build it is you practice memorizing. You memorize something. Okay, and then you memorize something else, and then you continue to rehearse, and that will build your ability to memorize. So the formula for slope, m is our value for slope, how the line moves, is going to be our difference. To find change, you need to find the difference, how things have changed. So we would be subtracting the y-coordinates. So it's the difference of the y-coordinates over the difference of the x-coordinates. So it's the difference of the y-coordinates over the difference of the x-coordinates. And if we were to write that in terms of using the coordinates themselves, it would be y2 minus y1, over x2 minus x1. Now I'm using the colors to help show that you want to line up the x and y coordinates from the same point. So here we did our second point coordinates minus our first point. Really doesn't matter which one is point 1 and point 2, you just have to match up the order. Okay, so order matters here. In terms of they have to line up. Okay, because you could also, or you could write it as, and we'll do a little subtraction here because it's the difference on the top and bottom. You could do the blue point, or the first point first. You could do y1 minus y2 over x1 minus x2. It really doesn't matter. A lot of textbooks and instructors emphasize this version, but this y2 minus y1 over x2 minus x1, but it really doesn't matter. You can do it this direction too, y1 minus y2, as long as on the bottom it's x1 minus x2. Okay, so you just always have to have consistency top and bottom, and that will take care of anything you want to do there with slope. Okay, so that's been a lot of information. We're finally getting to be able to do some of the math here. So here's what they'll first ask you to do. Find the slope of the line passing through each pair of points. Indicate if the line rises, falls, is horizontal or vertical. So I want to give you some information here of how you're going to deal with this. Rises means that it's going to be a positive value for slope. In terms of the line itself, it would be going up as you go from left to right. And for a line that's considered to be falling, that would be a negative value that you would find for slope. In other words, as you looked at the line from left to right, it would be going down from left to right. That's a negative slope. Okay. Now on the next page we'll deal with what happens when you end up with a horizontal or a vertical. What are the values that you get for that? And of course we know a horizontal line goes straight across like the horizon, left to right, and a vertical is going to be straight up and down. Okay, so those also get a value, or they have a slope, they have an assigned slope to them. So we'll investigate that at the next page. But for now, let's deal with either we're going to have positive or negative here. So we look at our value, our 2 points. You have to have 2 points to be able to find slope. And our 2 points are -1, 3 and 2, 4. For those of you that have been successful at slope in the past, you can just write your formula, because every time you're trying to memorize something, write your formula every time you use it and say it out loud, and just start plugging the pieces in. But if you're like me and you tend to drop negatives, or you question yourself, or you put one point incorrectly and then the other one you switch around, because remember, order matters. If you know you've had issues with slope in the past, or you always get them kind of reversed, then not only do you need to write down the formula, but you also should probably take a couple extra moments and identify which one is your first point and which one is your second point, and label them as x1, y1, x2, y2. That little piece right there, coupled with what we're going to do next, and that is to write out the formula. Slope is equal to y1 minus y2 over x1 minus x2. Notice I wrote it and said it at the same time. So now I've heard it and I've seen it. I'm getting this further into memory every time I use it. If you take the time to label each piece of your points, x1, y1, x2, y2, and then you write out the formula, you're not going to make many mistakes here. We just need to put our pieces in. And I go ahead and give myself some workspace. Every time I remove a variable and I'm about to replace it with a number, I copy everything else. So here's the fraction bar and the two subtraction signs. And then I put placeholders, and I'm using parentheses to kind of hold a number in place. And now I replace it. So now I do what I call the point method. What comes first? Y1. So I point at y1 and I put that in the first spot, 3. What comes next? Y2. And I point at y2 and I put that in the next spot. And that's going to be 4. And then x1. I point at x1 and I get -1. What comes next on the bottom? x2. I point at x2. That's 2. There's no question. I don't have to keep track. I haven't used up any energy to do that. The only energy it took was, as I'm beginning to memorize this formula, just writing that piece out. Okay? It would be just almost nothing short of tragic to get all the way to the test, and when you're asked for slope, you drop one of the negatives or you switch one of them around, when this technique guarantees you the right answer. You're just an arithmetic, 2 arithmetic problems away from getting the answer here. Okay, so what that translates to is 3 minus 4 over -1 minus 2. The parentheses now can move because now I'm for sure that I've got everything in place. So 3 minus 4 is going to give me a -1. -1 minus 2 is going to give me a -3. And a negative over a negative is going to be equal to a positive. So this is positive 1/3. So that means that as I move from point to point, okay, so 1/3, the slope of 1/3 means that as I move from point to point, I would go up 1, that's what that +1 means, and then I would go to the right 3. That's the movement here. It's your change in your up and down over your change in left to right, and they ended up being positive over positive. Now, some of you may wonder, well, what if there was a negative? Well, both of these negatives would take us down 1 into the left 3. And if you were to draw a line, and I'm just going to use up a little bit of the space here, and that's not a very good line. But if I've got a line that goes up 1 and over 3, this is not drawn to scale here, that would be a positive up 1 into the right 3. I could also connect from right to left, and I could go down 1 and to the left 3, I would still be on that same line. Okay, so negative over negative is equal to positive over positive. That's another convincer that dividing a negative by a negative should equal a positive. So it's when you start to really dive into the mathematics and why things work, I think it's pretty, to me, it's pretty awe-inspiring how it all comes full circle. This is not something that a group of people just decided to create. They didn't come up and they go, oh, hey, let's figure out a formula for slope. It was something that they observed always happens. So they didn't decide that a division by 2 negatives equals positive. It's because it's what makes sense with how our world works and the patterns that we see in the numbers and objects around us. So I think that's one of the cool things about mathematics, but who knows? So let's try number 8 together, and then I'll turn you loose on number 2. I'm going to go with, just at my beginning stages, I am just going to pick my points. Now, here's something I could have done to even help me more. I could have labeled this as first point, second point. Now, to show you that it really doesn't matter which one's your first and which one is your second, I'm going to call this 6, 4 my second point, 6, negative 4, and then this 4, negative 2, I'm going to call that my first point, okay? Because it doesn't matter. As long as you're consistent in plugging it into the formula. So again, what is that formula? Oh wait, I better label these first. So if I call this my x2 and y2, and this one my x1 and y1, just taking a moment to give them those labels, then as I write my formula, I'm subtracting top and bottom, and I've got y1 minus y2 over x1 minus x2. Or you could use the other version, which is y2 minus y1 over x2 minus x1, but since it didn't matter which point we picked, it really doesn't matter as long as you're consistent, as long as you've got the same point being represented in the first spot and the same point being represented in the second spot. Okay, so as long as the same point is represented in the first spot and the second spot, meaning the first item that you have in your subtractions, top and bottom, come from the same point. Okay? So if this is starting to click and make sense for you, put it in words that will help you remember what's starting to come together for you in your brain. So now it's the point and shoot method, so to speak. I write out my fraction bar, I write my two subtractions, I go ahead and give myself some placeholders because I'm taking the variables out and I'm putting values in. And it's a matter of point and point here. I'm looking for y1, I point to y1 that I've labeled, clearly labeled over here. It's a negative 2, I put it in place. I'm looking for y2 and y2, it's negative 4. Notice I put the entire negative 4 here. I've already copied the formula. The formula says to subtract. The number I'm putting in is negative. I'm going to be subtracting a negative. So those placeholders are really helping me not make mistakes here. Point and shoot method here. x1 is going to go right here, so I go find my x1 value, and it is going to be 4. And my last spot, it needs to be filled with an x2. It's going to go down here on the bottom, so I point at my x2, my x of my second point, and that's 6 here. Again, I reversed it because I wanted to demonstrate here that the second point, first point, doesn't matter which point you call first or second, as long as you line them up. Okay. From here, as we go ahead and subtract, we're going to get a negative 2 minus a negative 4, which is going to become a plus 4. And on the bottom, we get 4 minus 6. That is equal to negative 2 plus 4 is positive 2. 4 minus 6 is negative 2. So I've got a positive over a negative. That's going to give me negative 1 over 1. Or you could just write that as a slope of negative 1. Sort of helpful to leave it in terms of the fraction, though, so you can think about what type of movement this is. This is down 1 to the right 1 because we've got negative over a positive. Or you could think of it, because remember, negative has to be in one place or the other. It could be considered 1 over negative 1 too. That would take you to the right 1, and then I'm sorry, it would take you, sorry, y direction first. That would take you up 1 and then left 1. And again, if you were to draw a number, this one actually falls. Did we ever officially write that over here? On number 4, this is a this line rises because it's a positive slope. Okay, this line is going to fall because it's a negative slope. Okay, negative, and this one is positive. So as you look at it, this down 1, right 1, and up 1, left 1, in other words, negative over a positive, if I go down 1 and to the right 1, I land back on that line. But if I were to reverse that and go down 1 to the right 1, that would be negative 1 over 1. If I reverse that and go 1 over negative 1, up 1 to the left 1, let's pick another point. Let's go up 1 and to the left 1. I will be on that same line. So I can go down 1 to the right 1, which is negative 1 over positive 1. Or I can go up one and to the left one, which is positive over a negative, and those are equal to each other. You get a negative slope. It falls as you go down. So again, another little representation of, sorry, that should have been positive on the bottom. Another representation of why a negative divided by positive is negative, or a positive divided by negative is negative, or why it doesn't matter where you put the negative on a fraction as long as there's only one of them. Okay? Alrighty. Let's let you have this try problem. I know this particular video went long. There was a lot to talk about in terms of slope. I wanted to give you a really, really solid foundation for those of you that needed it to be able to move on. You don't want to be questioning how to do slope because those numbers matter. We want accurate slopes here. So you try this one, number 2. Find the slope and tell me if it falls or rises, if it indicates that you've got a negative slope or a positive slope on that line. Okay, so after you've tried that, you should get a slope of 3 over 1, or just positive 3, which indicates that that line is rising. It has a positive slope. So we will do that as a try together in class, and we will see you on the next page. Good job.